Okay, so we're on question number 22 in the related rates problems. All right, so I kind of drew this beforehand. We had a conical tank with a vertex down. So this is one of the questions that we started in class. Well, similar, not the same type. And it's on its vertex, and it's let's see, let's put in some numbers now. It's 10 feet across on the top. Okay, so it's 10 feet across on the top. Now, if it's 10 feet across on the top, then that's the diameter. We don't want the diameter, we want the radius. So the radius is half of the diameter. So you have to divide 10 here by 2 to get R equals 5. So this guy on top right here, let's call that big R, is equal to 5. All right, 5 feet. Okay, and then it tells you, okay, it's 12 feet deep. All right. So, the height, from here to here, and let's call that big H equals 12 feet. All right. Good. Now, what the question is asking you, if water is flowing into the tank at a rate of, and here we go, 10 cubic feet per minute. All right. What is the rate of change of the depth of the water when water is 8 feet deep? All right. So they're not asking you to find, the rate of change of the volume, right? But rather of the volume of the tank, but rather the volume of the water that's flowing into the tank. Okay? And that's the big difference. Okay? So the first thing we definitely know we're going to be using the volume of a cone formula, which is V equals, and this should be in the solutions manual. I'm just going based on what's in the solution manual. All right, this is just more for explanation. R squared times height. Okay, now this little r here is representative of this one right here. Okay, and this little h is not the height of the total height of the tank, but rather the height of the water at some point in time. All right, the depth of the water. Okay, which basically means from here, this piece right here. This piece right here is gonna be our little h. Okay, now um let's see what we have to find. All right, so let's write down what we have to find here. We need to find the rate of change of the depth of the water when the water is 8 feet. All right, now the rate of change of the depth of the water, all right, is going to be given by what? What do you think? Well, it's going to be given by here. The height, little h, determines the height or the depth of the water that's flowing into the water. All right, little h. Okay, that will give you the depth of the water at some point in time. All right, and since it's going up, this height is changing, or the depth of the water is changing. So we need to find the rate of change of the height of the water, or the depth. All right, I called it height, but it's really the depth. All right, so we're trying to find this rate of change right here is represented by this derivative dh with respect to dt. So dh dt. So we need to find dh dt. That gives us the rate of change of the depth of the water when, well, when the water level is 8 feet deep, right? When the water level hits 8 feet. So when what? When h, because h represents the water level, the height of the water. All right. So when h is equal to 8 feet. Good. So that's what we need to find. Now, let's see what we're given. Well, we're given a few things. All right. We're given the fact that the water is flowing into the tank at a rate of 10 cubic feet per minute. Now, cubic feet represents volume. All right, so this is a rate of change with respect to volume. All right, so therefore, they're actually giving you dV, the change. They're giving you the rate of change of the volume of water that's flowing into the tank. All right, So they're giving you dV dt, and water is flowing at a constant rate of 10 cubic feet, and then that would be that per minute. So let's write on the units for now so we can remember what units we're dealing with. All right. Now, so we're given that. We're also given some other stuff. We're given that the fact that big R is 5 and big H is 12. And we're going to have to use that. All right. So I kind of started this in class, but we didn't get to finish it. Well, for sixth period. Third period we did. So we're going to use that before we start differentiating. We're going to use that. Remember, we talked about the similar triangles aspect of a conical, right here of a cone. They have a similar triangles thing going on here, right? You have this small triangle, which is similar to the big one, all right? And you can get a proportion of that, all right? So for this case right here, big R over big H, is proportional to little r over little h. Okay, we know that. Okay, just using setting up a proportion. And we also know that big R is 5 and big H is 12. Okay, sorry, my bad. Let me erase that. So I said R over H. Okay, now there's a few ways I can do this. I can solve this. I could cross multiply. Let me cross multiply and see what I get. I'm going to get 5H equals 12R. Okay. Now, I am going to, when I find the derivative of the volume here using this volume formula right here, what happens is that I'm going to end up, I have two variables right here. I have R and H. So I'm going to have to end up using the product rule right here. And then things are going to get messy. So to avoid the mess, if I can use this somehow, if I can use this relationship right here and eliminate one of the variables, then life is good. Then I don't have to use the product rule. It's just a simple, straight up, derivative. So which one do you think I should get rid of? Well, the question is asking, find the rate of change when H is 8. So they give you H already. They're giving you at what, when the height is 8, they're giving you that. But nothing in here is giving something in terms of a radius. So I should try and eliminate R and, make a substitution for R in terms of H. So to eliminate R, I'm going to solve for R right here. All right, I'm going to divide both sides by 12. And I'm going to get R equals, 5H over 12. Okay? So the radius is, 5/12ths of the height, basically. All right? It's smaller. It's 5/12ths of the height. And I'm going to use this fact right here and plug it into here. So before I differentiate, I'm going to plug this guy into here, right, to eliminate R, right? So then I'm not going to have everything in terms of H. Good? All right, so that's the plan. All right. Now I'm kind of running out of space here, so I'm gonna have to probably erase this. Gonna have to probably erase this diagram right here. So bye bye. Okay, I think we're done with you. We don't need you anymore. And good. So I have some more space right here. Let me continue. So this is what I'm doing. I'm plugging in R here, this substitution for R into this formula. Notice I haven't found the derivative yet because I'm just trying to get everything in terms of H. So before I do that, let me go now. I'm going to have V equals 1/3 pi. And I'm plugging in my R, which is 5H over 12. And I'm squaring my R, so that's that, times the H that was on the outside. Okay? So when we do all of that now, we're going to square the top, square the bottom. So if you looked on the solution manual, you should see where they're at right now. When you square the top, you're going to get 25. You're going to get 25. And when you square the bottom, you're going to get over 144. Now, when you square H, you're going to get H squared. and then h squared times this extra h is going to give you h to the third power. Okay, so that's where they got that. All right, and then they cleaned it up a little bit more. They went one more step, and they went, okay, they went 25 pi. Just cleaned it up a little bit, put this in front, whatnot. And then they didn't even multiply this out. They just left it as 3 times 144. And that's fine. And then they had h to the third power right here. Okay? So now we can find the derivative. All right? So remember, this is v equals all of this. All right? V equals all of this right here. But everything now is in terms of h, so life is good. I don't have two variables to deal with like before when I had here. All right. So now now you find the derivative with respect to time both sides. So the derivative of v respect to time is going to be just dv over dt. Okay. And here, all of this right here is a constant. All of this here is a constant. So this is going to stay the same. All right. All of this here is going to stay the same. So I should be getting, well, what should I be getting right here? I should be getting 3. Put the 3 in front. Now when you put the 3 in front right here, the 3 is going to cancel out with this 3. Okay? So you see why they didn't multiply it out? Because when you put the 3 in front and subtract 1 from here, you're going to get h squared. So when you put the 3 in front right here, it cancels out with this 3 right here. Okay? So you're going to end up with 25. Whoops. Let me erase that. You're going to end up with 25 pi, right, over just 144. That's what the solutions manual had. So if you're wondering where did that 3 go, well, when they put the 3 in front, it canceled out with the 3 at the bottom. All right. Then minus 1 from the original exponent, so you should get h to the second power. Now, the key thing is times the derivative of h with respect to time. So you should get dh dt. Good? So that's what you get right there. Now, remember, we're trying to find what? We're trying to find dh dt when h is equal to 8. Good? So therefore, basically, what was given to us? Well, dv dt was given to us. dv dt is 10. All right. So if we put 10 here and solve this guy here for dh dt, we're going to end up with dh dt is equal to, now I'm just going to put 10 here, right? So I should have 10 on this side, and then end up dividing 10 by all of this. Okay. So I'm going to have 10 for dv dt. That's my dv dt coming from here, divided by all of this right here. So 25 pi over 144. Okay. Now h, you have h squared. Well, h in this problem, I want to find this when h is equal to 8. So I can just put 8 right here. This is going to end up giving, this is going to be what? 8 to the second power, because that's, when h is 8. And that's going to be 8 to the second power, that's 64. All right, so 64. Okay, so that's what that ended up to be. All right, and they put it like that in the solutions manual. And then, you do some simplification right here. And when you simplify, I'm not going to do it for you. This, you should be able to simplify this all on your own without a calculator. Okay, and when you finally do it, you should end up with 9 over 10 pi. Okay, now what is the units? This is the rate of change of the height or the depth of the water with respect to time. So since it's the height, it should be in feet per, and what was the time? Okay, I have to look back here, and everything was in terms of minutes, so it's feet per minutes. All right. So you could change this to a decimal, but this is perfectly fine, an exact answer in terms of pi. All right. So that's how fast the depth of the water is changing when the water is 8 feet deep. All right. Is represented by that rate. Okay. And that's how you do that problem. Alrighty.